All right, so today we're going to be doing area between two curves. We've done area under a curve, and if you'll remember, just as a real quick reminder, if we have a function y equals f of x, how did we find the area from A to B underneath that down to the axis?
The integral from A to B of x dx.
Thank you.
So is this area between two curves just subtracting?
Yeah. So the distance between two curves, it's going to be the upper curve minus the lower curve. So if you have a region where f of x is always greater than or even equal to g of x, the distance between them at any point c is f of c minus g of c.
What if the curves intersect?
That's an excellent question that we are going to take a look at. What happens not infrequently is sometimes they intersect and then they go back to it being the same way, but most of the time when they intersect, they switch places. So you're going to have a separate integral every time they switch places. Or if it's a calculator part, you can do the absolute value. So generally speaking, if f of x is greater than or equal to g of x, then the area from A to B is going to be f of x minus g of x, the integral from A to B of f of x minus g of x dx. That also works if one or more of them is negative. It doesn't really matter, as long as f is greater than g. So let's do some examples. Find the area between the graphs of f of x equals x squared minus 4x plus 10 and g of x is equal to 4x minus x squared on the interval from 1 to 3. All right, well, gonna need a quick sketch.
Just like the police.
Pardon?
Just like the police.
Just like the police. And we're only interested in what happens between 1 and 3. So I only need potentially the first and fourth quadrants. Let's see, x squared minus 4x plus 10. Well, I know that's an upward-facing parabola. And if I factor that, that's what? X plus 1. No. Does that even factor?
I don't think so.
Because I got to have two things that multiply together to be positive 10, but add together to be negative 4. They would both have to be negative. Yeah, that's not so much going to work. However, I do know that the y-intercept is 10. I'm like, okay, so I don't know exactly what this looks like, but it looks kind of like that. And likewise for this, 4x minus x squared. Now that one I can factor. Factors to x times 4 minus x, which means it has a 0 at 0 and a 0 at 4. So let's see, what is this one at 4? That one's 10. So this one looks something like this.
Like the Under Armour logo.
It does look a bit like that, doesn't it?
Call it Over Armour.
So the question is g of x always over f of x on this whole interval?
No. Wait.
Well, the interval from 1 to 3.
Yes.
Well, let's set them equal and see where these two actually intersect each other. X squared minus 4x plus 10 is equal to 4x minus x squared. So that'll be 2x squared minus 8x plus 10 is equal to 0. So that'd be 2 times x squared minus 4x plus 5 is equal to 0.
-5 and 1.
But that would be,
Can't factor this. Oh.
right? Yeah, that doesn't factor very well. So what is our other option when it doesn't factor besides using the calculator?
Quadratic formula.
The quadratic formula.
I forgot. It's -b.
So that's going to be, I prefer to say the opposite of b because it's already negative,
Yeah. Okay, the opposite of b.
plus or minus,
Square root of b squared
which would be 16,
plus 4ac.
minus 4ac.
Same difference.
It's a huge difference.
Would it be 2 or 1? It would be 1.
Yeah, we're factoring this. We're solving that part is equal to 0. So that's going to be minus 4 times 5, so minus 20.
Over 2a.
So that'll be over 2. This doesn't have any real roots.
Oh, dear.
Something's not
I
right.
don't think this was supposed to be an imaginary number problem.
No, I'm sure that it wasn't. Now let's graph this on the calculator. I feel like I'm doing something wrong, but I have no idea what, and I don't want to sit there and stare at it for 5 minutes.
This is how we feel on the homework sometimes.
So x squared minus 4x plus 10.
Watching the answers.
No real roots.
And the other one is 4x minus x squared. And I'm only interested on the integral from 1 to 3. Oh, okay. My f of x was poorly drawn. Turns out that f of x is not like this. It turns out that f of x is actually more like this.
Like
Pardon?
I don't really know what that looks like.
It's a bow tie.
Kind of looks like a smiley face. Or angry face. Smiley face.
So it turns out that f of x is always greater than g of x. And that explains why we couldn't find a point of intersection. There is no point of intersection. So the area would simply be the integral from 1 to 3 of f of x, which is x squared minus 4x plus 10, minus g of x, which is 4x minus x squared, dx. And we've already done that subtraction. We did it right up here. So this is going to be the integral from 1 to 3 of 2x squared minus 8x plus 10 dx. So this is 2/3 x cubed minus 4x squared plus 10x from 1 to 3. Let's see, that's going to be 18 minus 36 plus 30 minus 2/3 minus 4 plus 10. Let's see, that's 12. And that's going to be 6 2/3. 6 1/3. Wait a minute. 6 2/3. So it's 5 1/3.
Yeah.
So sometimes they don't intersect one another, which was the whole point of doing all of this. And when they don't, we just take the higher one minus the lower one on the interval. But that's not always the case. So let's find the area enclosed by the graphs of x squared minus 5x minus 7 and g of x equals x minus 12. Now that's a line and a parabola. Seems more likely that they would intersect. Maybe they don't. Let's find out. So x squared minus 5x minus 7 is equal to x minus 12. So that'd be x squared minus 6x plus 5 is equal to 0. Oh, hey, isn't that nice? X minus 5 times x minus 1 is equal to 0. So either x equals 5 or x equals 1. So that's where these two intersect. They intersected x is 1 and they intersected x is 5. In between those two, which one is going to be higher and why?
It's going to be the line g of x.
Yep. How do you know that?
Because it's a parabola with a line. I can see it in my mind at the intersection points of those.
The parabola has a y-intercept.
And the parabola is facing upwards.
The parabola is facing upwards. Since the parabola is facing upwards, if they intersect, the line's got to be above the parabola on that interval. It's the only way it's possible. So the area is going to be the integral from 1 to 5 of the line x minus 12 minus the parabola x squared minus 5x minus 7, all dx. Notice that here we took the parabola minus the line, right, when we were solving. So that means if I subtract in the other order, it's just the opposite signs. So it's negative x squared plus 6x minus 5 dx. What? I just took, here I did the parabola minus the line, right? So if I want the line minus the parabola, it's the same values, just the opposite signs. So this would be negative 1/3 x cubed plus 3x squared minus 5x from 1 to 5. Let's see, that's negative 125 thirds plus 75 minus 25 minus negative 1/3 plus 3 minus 5. Let's see, that's going to be 50 minus what? 41 2/3.
So 9 1/3.
8 1/3
Oh yeah.
minus, this is going to be negative 2 1/3. So that'll be plus 2 1/3 is 10 2/3. Pardon?
Wow.
I could have sworn you said 1/2, and I was like, what? All right, so let's do this one. Find the area between the graphs of this parabola and this line on the interval from negative 2 to 5. Yes?
Can I take a gander of what the setup will be?
A gander?
Yeah, you know, what you guess.
A gander is not a guess. A gander is a look.
Well, yeah, thank you for educating me on my wrong
Colloquial use.
Lexical knowledge.
So what is it you think is going to happen here?
The area is going to equal to the integral from 1 to 5.
You mean from negative 2 to 5?
I mean, I'm going to split it up.
Why are you splitting it at 1?
Because that's what we used in the previous problem.
Is it the same?
Yeah.
Yeah, it's the same.
Okay. So in the previous one,
Why can't we just make a full interval?
where did these intersect?
1 and 5.
What do you do with that extra area, though?
So we know about this part, right?
Mm-hmm.
But we also want to go all the way over here to x is negative 2. And we want this area as well.
Negative 2 to 1. Then we just add our old answer.
Yeah, so we're going to have to take the area is going to be the integral. Let's go ahead and set it up. From negative 2 to 1 of the parabola minus the line. So x squared minus 5x minus 7 minus x minus 12 dx plus the integral from 1 to 5 of the line minus the parabola. And I should have left more room. So if they intersect somewhere inside of your interval, they may change positions. So this is going to be the integral from negative 2 to 1 of x squared minus 6x plus 5 dx plus, what did we get on the last one? 10 2/3? So that's 1/3 x cubed minus 3x squared plus 5x from negative 2 to 1. So let's see, that's 1/3 minus 3 plus 5 minus 8/3 minus 12 minus 10. By the way, at that point, if this is a free response question, you can leave it. But let's go ahead and crank out the numbers here.
Could we have left it sooner on the previous one as well?
Yeah. Let's see, that's negative 22 and a positive 2 2/3. So this is minus 19 1/3. So that's 12 13, 32 and a third, if we've done all that correctly.
Yeah. Well, I got 30. Yeah. 30.
So I will say on the AP exam, these have gotten to be less like these where it's lines and parabolas. We did a lot of lines and parabolas in the old days because we wanted people to be able to do it by hand. And then when calculators became, ubiquitous, then they're like, okay, we can do more interesting graphs.
So this would be a calculator problem if it was more interesting.
Likely. And you would have to find points of intersection, and the points of intersection are likely to be ugly.
But we probably wouldn't have to do an ugly one by hand.
Correct.
Okay. You really have a thing for college porn?
Yeah.
You're gonna work there someday.
Absolutely not.
As their computer engineers improve their online grading experience.
So let's take a look at this one. Find the area bounded by the graphs of y equals 8 over x squared, y equals 8x, and y equals x.
A straight line. All lines are straight.
What's the opposite of a curved line?
Well, since there is no curved line in geometry, then
All lines are straight lines.
What do you call a parabola?
it's a curve. It's not a line.
You know what's the opposite of a curve? A line segment? No.
And why does there have to be an opposite?
There has to be something that means straight, not curved.
Line.
Line. We have a line.
Oh, so a curve wouldn't be a line.
Correct.
Oh, okay.
We have a line, another line, and
The pre-cal rod in my brain in the geometry division.
All right, so let's take a look at what we've got here.
I studied the unit circle last night.
Did you?
Yep.
So what's cosine at pi over 6?
1. Square root of 3 over 2.
Nice.
this is an ugly graph.
Anytime people say things like that, I have this infantile reaction that makes me want to say, your mom was an ugly graph.
That's something I would say.
I also had a similar thought.
It looks like modern art.
We should do like a zoom standard here.
I am.
It's a volcano.
A what?
The volcano.
A volcano.
A volcano? I think you're putting the emphasis on the wrong syllable.
That was pretty good. Either that or a nuclear cooling tower. Well, what do we graph here?
So what we're looking for is this little region in here, right? We want it to be bounded by these three curves. So it's always bounded below by the line y equals x, right? But it's bounded above
By those lines.
by the line y equals 8x at first, and then it's bounded above by this curve.
So do you have to find where the curve and the line intersect?
Yeah, we need to find where the curve and the line intersect. We know that these intersect at 0, 0, but then we also need to know where the curve intersects the line y equals x. So we've got lots of intersections to find. So we want to know, well, first of all, what's this point? Let's do it by hand and see if we can. I'm pretty sure we can. So we're going to have 8 over x squared is equal to 8x. So dividing both sides by 8, multiplying both sides by x squared, we get 1 equals x cubed. Hey, isn't that nice? X is 1.
Is this where the line and the curve intersect?
How?
This is, well, there's two lines. So when you say the line and the curve, It's where y equals 8x intersects 8 over x squared. And then y equals x intersects 8 over x squared. That'll be x equals 8 over x squared. That'd be x cubed equals 8. So x is 2.
Yes.
So on the interval from 0 to 1, we've got the line y equals 8x is the upper curve, minus the lower one is y equals x. Plus, on the interval from 1 to 2, the upper function is 8 over x squared, and the lower function is still y equals x. So that's going to be 7x. So that will be 7 halves x squared from 0 to 1. Plus, let's see, that's 8x to the negative 2. So that's going to be negative 8x to the negative 1 minus 1 half x squared from 1 to 2.
Would this be a free response problem?
Could be a multiple choice. So this is 7 halves plus, see, that'll be negative 8 minus 2, so that's negative 10. Minus, at 1, that's going to be negative 8.5. Something's not right.
It would be
It can't be. It's an area. If we've set it up right, there's no way the area should be, and I'm just talking about for this second integral. Because that should be this little bitty area inside of here, right? Clearly doing something wrong. That's negative 8x. So the derivative of that is 8x to the negative 2. That's right. The derivative of this is negative x. That's right. At 2. Oh, stupid. Negative 8 times 2 to the negative 1 is negative 4.
A little bit of difference.
So actually, let me fix this whole thing. All right. So when I substitute 2 in here, that's going to be negative 4. Minus, when I substitute 2 in here, that'll be 2. Minus, when I substitute in 1, I'll have negative 8 minus a half. So that's 3.5 plus negative 6 plus 8.5. So it'll be 9, 10, 11, 12 minus 6 is 6.
That's a lot of work.
Yeah. All right. Questions? Okay.